Hi everyone, my name is Thomas Kim. Today is February 2nd, 2020. This is my 15th episode about 3D graphics, Intel TBB, OpenCL, Vulkan, Direct 3D 12 using Microsoft Visual C++. This is forward substitution and parallel do algorithm 2. If you haven't watched my previous episode, please double-click this link and watch my previous episode. Otherwise, you may not be able to follow my current session. In this episode, we will implement algorithm in ProTBB page 56, figure 222, a blocked version of serial implementation of forward substitution. If you do not have ProTBB, please double-click this link. From this website, you can download the PDF file for ProTBB. Please double-click this link. Then click this button to download the PDF on your machine. Also, by clicking this link, you can download the source code of ProTBB. Please double-click this link. Then clone download zip. Show in folder. If you unzip the downloaded file, Chapter 2, Figure 222, this is the source code. Also, in this PDF file, Chapter 2, this is Figure 222, this code. This code has some problem. The problem is that the block size 512 and the array size, the size of n, should be divisible by the block size. If n is not divisible by block size, this algorithm does not work. We will fix that problem in this episode, and we will solve system of linear equation using this algorithm. I will post this script in the description section below. In the download source code section, please double-click this link. Show in folder, unzip it, rename 2. Copy the folder, paste it to your working folder. This is my working folder. Paste it here. Start Visual Studio Code. Open your working folder. 15 forward substitution 2. Double-click forward. Ctrl V. Please note that I assume you have watched my previous episode. If you haven't watched my previous episode, please double-click it and watch my previous video. Then come back to my current episode. Control Home, include Talk Play Fun, Chrono Random. We need random number generator. Control End. We will copy this function, test sequential forward substitution. Scroll down, copy, paste. Scroll up, test, blocked, sequential forward substitution. I will put demarcation here and copy the function name. Copy, Control End. We will paste it here and I disabled this part. Now scroll up. Right before test blocked sequential forward substitution, auto blocked sequential forward substitution. Matrix 2D double proximity L value reference A size T block size. I will put it any number, for example 4. At this point, using proxy matrix T DECL type A, talk, play, fun, remove constant reference T. So we define the proxy matrix T using matrix T proxy matrix T matrix T type name using element T type name matrix T. It has a member called value type. We can also do like this: matrix 2D element T matrix T. We can also do this. Now here, using solution T matrix scalable fast vector element T, we define the solution type size T n A rows, size T columns A columns. N is the row count of matrix A. Size T last column columns -1. Last column index. Size T num blocks. Number of blocks. If block size, this block size comes from here, is greater than or equal to n row count, then num blocks, it should be 1. Else num blocks n divided by block size. If n is not divisible by block size, it means row count is not divisible, not evenly divisible by block size. Then num blocks, we have to increase 1. Okay, now solution Tx n. N is row count of the matrix A. Return x. We will put more code here. Now at this point, stream n row count n num blocks num blocks block size. Now I will copy this function, copy, scroll down, test block sequential forward substitution here. We will paste it here and scroll up, test blocked sequential forward substitution. I will remove these comments. I will delete this part too. I will delete this part too. So I deleted, I cleaned up some code. I will delete this part too. I will remove all comments. Now start your command prompt. dir cd 15 forward substitution 2. dir cl ehsc std c++ 17 forward.cpp fe m.exe, hit enter. cls m. This is 3 by 4 matrix. Row count is 3. Number of block is 1. Block size is 4. If we change to block size to 1, if we build again, now block size is 3. Block size 1. Control home, namespace, chr, talk play fun, chrono random. I introduced chrono random namespace alias here. Control End, scroll up. In this function, I will put it 10. And the row counts. Column count is row count plus 1. Now we don't need this part. Here, auto generator ins chrono random generator int. The range should be -9 plus 9. Return element t. Element t is defined here. Ins. This is random number generator. chr random fill. A array generator. Now row count is 10. Now I will change it to 3. Okay, this is block size. Scroll up. This is block size. I set default 4. Or I can just remove default block size. Now we build once again. cls m. So this is 10 by 11 matrix. Block size is 3. So number of blocks should be 4. For example, if block size is 5, then m number of block is 2 when block size is 5. It means we divide n by block size, then we have block count, number of blocks. While watching this video, please refer to this document. Now scroll up. In this part, for size t r, r means row, num blocks plus r. For size t c, c means column. C should be less than and equal to r. Okay, don't forget equal here. Then plus C. In this configuration, R and C represent bigger blocks. In this case, R0, C0, R1, C0, R1, C1, R2, C0, R2, C1, R2, C2. So stream RC, RC, stream NL, this is new line, control home, auto, NL, talk play fun, NL, this is new line character, control end, here once again, now stream, and there. We will build once again, CLS M, RC00, 1011. I will disable this part and decrease the block size 2. If we build again, CLS M, okay, please note this configuration. I will make it 12 and we divide by 3. Then we rebuild CLS M. Okay, now we compare with this PDF. This block is 30, 31, 32, 33. So RC represent bigger block. Now we understand what R and C represent. I will disable this part. In this part, size T, I start, R times block size, size T, I end. I start this number plus block size. This part is very important. If I end greater than n, n is low count, then I end should be end. Size T, J start, C times block size, size T, J end, J start. J start is defined here, block size. In the same manner, if J end is greater than n, J end should be no. It should be I end. Okay? J end should be I end. Because J, the column is dependent on row. J, the column is dependent on row. So we have to set like this. This part is important. Please understand that this code does not work when the row count n is not divisible by block size. So we have to fix our code like this. For size Ti, I start, I less than, I end, plus plus I. For size Tj equals J start, J less than, J end, plus plus J. A, I, last column, minus equal A, I, J times X, J. We are covering this part. In this part, BI amounts to AI. BI equals AI last column. Okay? We are handling this part of code here. Now I have to block like this. If I equals J, X I equals A I last column over A I. Okay, This part amounts to this part. This code is erroneous. This code does not work correctly when block size does not evenly divide n. So we should fix like this. Now I will remove this code. Now we build once again. CLS M. This is the solution of our matrix. Now I will remove this code, this message, control home. We don't need this message. Now scroll down. We don't need this. Now scroll down. I will re-enable this. And like this. I fixed. We rebuild CLS M. So this is the matrix, 10 by 11 matrix. This is the solution. It gives correct result, true. For completeness of our algorithm, scroll up. Now we will change it to template function. Template type name, proxy matrix type. Copy, paste. It should be R-value reference. Now scroll down. In test blocked sequential forward substitution function, I will disable print. Then I will make it bigger. For example, 1000. Here, auto, parallel, random, CHR, random generator. Now it is double. Minus 10 plus 10. I will disable this part. CHR, random parallel fill, A, array. I will copy and paste it here. So this is 1000 by 1001 matrix. 1000 by 1001 matrix. In the command line, we build again. CLS M. It will take some time. So this is solution of 1000 element of X. The result is false. Now click this button. Double click matrix 2D. In this file, matrix 2D HPP, Control F, tolerance double. Make it 6. Now we build again. CLS M. We modify the tolerance double. Now, is the solution of matrix A true? In my next episode, I will address the problem of tolerance of numerical analysis. Also, in my next episode, or episode after next episode, I will implement this algorithm, implementation of forward substitution using two parallel. I will upload complete source code to my website. By the time you watch this episode, you can double click this link and download complete source code. Please subscribe to my YouTube channel. Thank you for watching.